When we work with correlation and regression, we have very valuable information in a statistic called the coefficient of determination. There are two pieces of information from the coefficient of determination. First, we can explain the variance in a variable from the variance in another variable. And second, we can look at the goodness of fit for the prediction line. Let's do a quick review of variance. You know that the standard deviation is like an average of how far from mean the data points are. So if I gather the number of hours on average that each student spends on homework, I can determine that the mean for the group is 6.04. Each student's time has a distance or deviation from that mean. For student E, that deviation is negative 0.204. For student G, that deviation is positive 1. So the standard deviation for the group is like the average deviation from the mean. In this case, the mean is 6.04 and the standard deviation is 2.34. The variance is very helpful mathematically. It is simply the square of the standard deviation. So for our last example, the standard deviation is 2.34 and the variance for that group is 5.48. But what does that tell us? What it tells us is that there are many differences in the individuals or in the group. So let me give you a conceptual example. If I look at the group of students from which I collected the data on their hours of homework, I would find a lot of variability. Every student contributes different things to the group. And if I want to see if there's a relationship between the hours of homework students do and the number of years of education their parents have, I'm introducing variability in the parents group too. Perhaps there is no relationship between these variables. So my Pearson correlation would be 0. But perhaps that relationship is 0.50. And that would mean that there are places where the variance between these two groups overlaps. Perhaps there's a really strong correlation between these variables and a lot of overlap in the variance. So it would be really valuable to be able to quantify the proportion of that overlap. We do that with the coefficient of determination. And all that is r squared. So if the correlation is 0.50, the coefficient of determination is 0.25. And I can say that 25% of the variance overlaps. If the correlation is 0, there's no overlap. And if the correlation is 0.90, the overlap is 81%. So what can we report or say using the coefficient of determination? I start with the statistical summary for the correlation. So I say that there is a statistically significant, strong, positive correlation between hours of homework and the parents' years of education. R equals 0.58, P equals 0.037. Then I can say, using the coefficient of determination, that the years of education for the parents accounts for or explains 28% of the variance in the hours of homework. Another example, I can find that there is a statistically significant positive correlation between high school GPA and freshman GPA. So I want to know how much of the variance can be explained by the high school GPA. By squaring that correlation coefficient, I can say that almost half of the variance in freshman GPA can be explained by the variance in the high school GPA. The second use of the coefficient of determination is for deciding on the goodness of fit. A larger coefficient means there's less error or deviation from the prediction line. So r squared of 0.49 is a better fit to that line than r squared of 0.36. This makes a really good rule of thumb for comparing. However, please note this. If you have it, you use the significance value for the regression model. It's always best to report that rather than relying on the coefficient of determination. So to sum up, the coefficient of determination is the r squared. It tells us the proportion of variance in y that's accounted for or explained by x. It also tells us the goodness of fit for the line. With just two variables, this information is useful. Imagine, though, that you had a regression that had more than one predictor in it. We call this multiple regression. With several predictors, you can actually use the coefficient of determination to tease out how much variance is explained by each predictor. We can even see if there is a compound explanation by adding in predictors. Way beyond the scope of this course, but you can see how interesting that would be.